Hey guys, this is Matt Hoos with Sawhorse, and I am at Stone Mountain here in Georgia. Beautiful day, and we're coming up on Independence Day, and I want to talk about not necessarily Independence Day, but Energy Independence Day. Now, this is the day that your house and your lifestyle is basically energy independent from the grid. So let's talk about the steps to get to that point, because a lot of people think that you're just going to take an inefficient house, throw solar panels on it, throw in some sort of renewable energy, and you're all set. Well, there's actually several steps that you need to do to get to that point to be energy independent. So if you have an existing house and you're looking at adding solar and you want to be net zero energy, the first thing to do is look at an energy model of the house, see what steps you can do to become efficient. When you're dealing with existing houses, it's a lot more difficult. Our recommendation is either looking at making energy efficient from the inside or just doing it all from the outside and then dealing with the HVAC. So let's look at several houses that we're working at right now. One is the 1920s makeover EATL. Now that's technically a renovation because there are some existing parts to the house, but it's a new house in the way we're designing it. So we're designing it like a new house with the air sealing, the building envelope, the energy efficiency applications, and then we can add solar to it. So when you're dealing with energy efficiency, the first thing you need to do is make sure that the building envelope, which is where your air barrier, air sealing, and also your insulation meet. Now, the more efficient you make this, the less you have to rely on HVAC, which is the #1 consumer of energy in any type of structure. Now, this is typical for commercial and residential, so these basic principles apply. Now with the 1920s house, we're making this a passive house. So a passive house is this type of certification where you're super energy efficient, and then it has to be net zero energy ready. So you don't necessarily have to add solar to a house. In this case, we are probably going to add solar to this at the very end, or at least give the homeowner that option, but it has to be net zero energy ready, which means that it's plug and play. You have all the wiring and everything set up on the electrical panel so you can add solar. I'm a huge fan of keeping things super simple. So what we did on the 1920s house is we took the air seal and we put that on the outside. We used the Hubert zip system. We used Advantech, the zip wall, the zip sheathing all around the house, and we used liquid flash to air seal. Now, a lot of people, and this is a misconception that I see in the industry, I see lots of other builders doing this, they'll have an air seal on the outside, they'll have an air seal on the inside. Really, you just need to pick one layer, do a really good job with that, and then you can get that ACH 50 down to, in our case, we got it down to 0.3 before we even did any punch out, and I really think we could have got it down to 0.15. Now, to put this in perspective, the National Energy Code is 3 ACH 50, so this is 10 times better than the National Energy Code. In Georgia, it's 5, some states are 5. Passive house is 0.6, so this was double what passive house required, and that was simply just by sealing all the seams in the plywood. So along with making sure you have a nice tight air seal in the house, we're going to add insulation. In this case, we're adding rock wool insulation to the outside of the house. We've got 8 inches of insulation added all the way on the walls, and we're putting 10 inches on the roof. Now we're using fasteners to attach this to the outside. And the reason we're doing this is we want continuous R value all the way around the house. Now what this does is eliminates thermal bridging. Thermal bridging is like if you have insulation between the studs, a stud is only R1 per inch, where the insulation is typically R4 per inch. So if you have continuous insulation on the outside, you eliminate all that thermal bridging that is coming through framing in typical construction. So air sealing and insulation are only 2 parts that we're looking at. We also need to look at windows and doors. You want to make sure that you're speccing windows and doors that have a good solar heat gain coefficient based on your energy modeling, and also a good U factor. This all has to do with the efficiency and also how it interacts with the elements such as the sun. Now, most good high performance windows are going to have a nice tight air seal, so you don't have to worry about air going around the windows and through the windows. But just because you specify a good window and door doesn't necessarily mean that it's going to install properly. So you need to make sure that it's installed properly. You use a blower door, pressure test the house, make sure you don't have any leaks coming in around the windows and doors. Now, I know a lot of window and door manufacturers, they like to say, hey, we're installing new windows and doors and it's gonna make your house more energy efficient. There's a certain truth to that. However, if they're not dealing with the casing and all the way around the window and door, it's only maybe reducing it by half of the air leakage that it could be reducing it by. That's why whenever we recommend replacing windows and doors on an existing house is do a full replacement. So when we first started on the 1920s, makeover ATL, it was a super leaky house. Now, Corbett Lunsford said this was the leakiest house he ever tested. We're close to, I think, 20 or 21 ACH50, which is 4 to 5 times either the Georgia Energy Code or the National Energy Code. So it's a very leaky house. Now, if we left it like that and just did a renovation instead of like a full deep energy retrofit, we would have had to put about 15 to 16 tons of HVAC into this house based on the house being close to 5,000 square feet. Now, because we got it down to 0.3 ACH50, which is much tighter than 20 ACH50 by a factor of close to 60, I believe, we were able to put a much smaller HVAC system in. So there's really savings on two different sides. It costs less to install a more efficient system because you don't have as much ductwork, you don't have to pay as much for the equipment, and also on the operating side, you don't have to worry about paying for high utility costs. So when you're thinking about putting solar on a house, if you have a super inefficient HVAC system, it's kind of pointless. Really, if you're looking for bang for the buck, work on the efficiency, make a tight building envelope, put an efficient HVAC system in, then add the renewable energy. So one of the misconceptions with solar is that you put solar on your house, it's going to supply you that free energy, which is true. However, you have to have a certain amount of surface area on the roof to accommodate the solar panels, and you also have the right orientation. So typically most people install them on the south side of the house. In some cases, they install them on the west side of the house because that's usually where they're trying to reduce the operating cost if there's a peak energy load and if the utility rates change. And again, we don't have that issue here in Georgia, so we typically install it on the south side of the house. Well, there's only so much area on the south side of the house to install these panels. So if you have a super inefficient house, there's only so much solar that you can add to offset that. Now, if you have a super efficient house, like we do on the 1920s house, we don't need as many panels, and we actually did the calculations. If we install solar on the south side of this house, this could be a net zero energy house and possibly a net energy positive house, which means that you're producing more energy on this house than you're actually using inside the house, which means that you're making money by adding solar. The only way to do this is to make sure you have efficiency first. The last point I want to make about solar is people look at solar as a way to make money. Like, hey, what's the return on investment? How am I going to be able to put solar on the house and sell it back to the grid? Well, the challenge is, like, say if you have a ice storm or thunderstorm and the power goes out, if you're selling everything back to the grid, you're not able to use that power yourself. So I preach resilience first. So if you have solar on your house, you need to look at some way of storing that excess solar, use the solar that you need during the peak loads, store the extra that you don't need. That way you have solar at night. Because if you look at the detractors with solar, they're like, well, you don't always have solar or wind all the time, and that's true. It's intermittent energy. So if you want to be able to make that a more reliable way of supplying power for your house, you have to store the excess energy. That way you have that renewable energy all day long. And many of my friends that lived in Texas during this latest ice storm, not only did they have water lines that they had to worry about, they also had to worry about gas infrastructure and electrical infrastructure. So a lot of the detractors say, like, I don't want to go all electric because if the power goes out, then I have to worry about not having energy, and that's why I have the gas backup. Well, I think the cleanest way for you and your family is to go all electric. And the reason I want you to go all electric is that you can have that solar power. And also, if you have those battery packs in your house, you can store the extra energy. Now, you don't always have to have solar to have those battery packs. So this is one thing that I've been telling people, like if they have a lot of trees, but they still want to be insulated from power outages or brownouts or blackouts, because of either the storms or there's an inefficient grid, you can save that extra energy off the grid in battery packs and then use that during either off-peak or during peak loads, if you're storing the energy during off-peak loads, or you can just use it when everyone else doesn't have power. I definitely encourage you guys to join us on the journey of taking a passive house. Now, the first ever passive house in Georgia, from conception to reality. We are in the mechanical phase right now, so I want you to check out our website. Now, we've got a virtual tour so you can see the different phases, and we've got lots of articles and also blog posts and videos on the website as well. You can check in the description below for a link to that. Now, some of the things that I want you to consider for your house, because not everyone could do a passive house. And I'm not saying that everyone needs to do a passive house. To get to net zero energy, it's a simple formula. All I have to do is look at the total operating cost of your house for the utilities, especially electric, because solar can only provide energy for electric. You can't provide offsets for gas, and I think that's something that when people are doing the calculations for net zero energy get confused about. So I want you to lower your operating costs as much as possible. Look at how you can add solar to your house, and also how you can use solar to negate the total operating cost of your house so you can be net zero energy. The reason we're shooting for net zero energy is, well, let's face it, energy costs are going up. A lot of places have said they've seen like a 15 to 28% increase during the pandemic, and it's not going to stop. I've never seen utility prices go back down after they've gone up, so this is the new norm. So to be insulated from the rising cost of energy, you have to work on the amount of consumption first, reduce the amount of consumption, then add renewable energy. In the spirit of Independence Day and also energy independence, I've got several other videos. Check out those videos off to the right-hand side. And if you have not subscribed yet, make sure you hit the subscribe button and the notification bell so you can see more videos just like this. Thanks again. See you guys next time.